Okay, today we're going to be talking about greatest common factor and least common multiple and how to use them and what they are. So to look at this first, we want to see that the definition here is the greatest common factor of two whole numbers, not both zero, is the greatest whole number that is a factor of each number. Now, a factor is what we multiply together to get a product. The two numbers that we're multiplying together are factors. The greatest common factor of two whole numbers, A and B, is denoted by the GCF, or the greatest common factor, AB. The least common multiple of two whole numbers is the smallest whole number greater than 0 that is a multiple of each number. The least common multiple of two whole numbers, A and B, is denoted by the LCM, least common multiple, AB. Okay, so just to start off there, when we're talking about greatest common factor, we're going to find the greatest common factor of 12 and 18. And this is how you're going to do it. If you'll follow these steps, you'll be good to go. Listing these factor pairs in order helps ensure that no common factors are missing. Start with 1 multiplied by that number. Okay, we've done this a little bit before, but here it is. So here's 1 and 12 for 12. Okay, 1 and 12. We also have 2 and 6. Then we have 3 and 4. Now, on this next one, it would be 4 and 3, right? And those would just cross over. Okay? Once they cross over, you know you're done. Okay? Because you're only going to get the next 6 and 2 and then 12 and 1. So you know you're done. Now, let's go ahead and do 1 and 18 for 18. We have 2 and 9. And then we have 3 and 6. And this is where they would cross over. 4 and 5 doesn't work because that would be, it's not divisible by 18, neither 4 nor 5. And so here they would cross over back to 6 and 3. Okay, so we don't care about that. We're done. And now it says circle the factors that appear on both lists. Well, 1 and 1, 2 and 2, 3 and 3, and that's it. Now it says place a triangle over the greatest common term, or factor. And so 3 would be our greatest common factor of 12. Oh, no. I messed up, didn't I? See there? We actually have 6 and 6. Just spied that. So 6 is our greatest common factor. Sorry about that. All right, let's do some least common multiples. Now, least common multiples are a little bit easier, although it takes a little bit longer to do because you're having to list out a whole bunch of numbers. So it says find the least common multiple of 12 and 18. Now remember, a multiple is just simply like multiplying. 12 times 1 is 12. 12 times 2 is 24. 12 and 24 are the multiples. 36 would be a multiple. So it says write the first 10 multiples of 12. So we would say 12, 24, 36, 48, 60. And then I'm going to, instead of keeping going a long way, I'm going to come down here and say 72. And then it's going to be 84, 96, 108, and 120. Okay, those are the first 10 multiples. Now, write the first 10 multiples of 18. Well, here, 18 is going to be a little bit harder. 12 I kind of know because I'm talking about feet and inches. I kind of know those. 18 is a little bit complicated, but I'll show you a little trick here. We can add 2 here, which is going to give me 38, and subtract 2 here, and that gives me 36. So you're adding 2 or adding 20 to it and then subtracting 2, right? Because 20 minus 2 is 18. So I'm going to add 20 and then subtract 2 from it. So here we had 36. If I add 2 here, that is 56. Subtract 2, that is 54. Okay, so I'm going to do that, and that's kind of my little trick for 18. Okay, so we had 18, 36, 54, 54, and that would be 72, and then we would have 90. Okay, and then I'm going to come back down here, so keeping on going. The next one would be 108. 126, 144, 162, and then we would have 180. Okay, so now that we have those, it says circle multiples that appear on both lists. Okay, 12 does not, 24 does not, 36 does, 48 does not, 60 does not, 72 does, 84 does not, 96 does not, 108 does, and that's all we're going to have. Okay, but now remember what we're talking about. We want to have the least common. So really, as soon as we find the first one, that's going to be our answer. Okay, 36, because we're looking for the least common. We're not looking for the greatest. We're only looking for the least common. So that's going to be your answer there. Okay, so that's how you find both of them. Now, if you see these that are highlighted, this is what you're going to do for classwork. Okay, if you want to go ahead and do it, that's fine. But this will be what you're going to do for your classwork. So I'm going to skip the ones that are highlighted for you to do during class. Now, this says exercises. This exercise is station 1, and we're just doing factors and the greatest common factor. Okay, so I'm going to do these that are not highlighted, and then I'm going to let you do the other ones. So, and if you want to do those on whiteboard chat or on your paper, that does not matter either way when it's your time to do it. Okay, so let's look at greatest common factors. Once again, what are we going to do? We're going to list the two factors, what we're going to multiply to get 30 and what we're going to multiply together to get 50. So if I do that, I get 1 and 30, 2 and 15, 3 and 10, 5 and 6, and that's where I would cross over, right? So I can stop there. Let's do 50 now. So this is 30, this is 50, 1 and 50, 2 and 25, and 5 and 10, 5 and 10. Now that I've got them all listed, I can say, what's the common ones? Well, of course, 1 works, 2 works, 5 does not work. I'm sorry, 5 works, 3 does not work, and then we have 10. So the common factors are 1, 2, 5, and 10, which means the GCF is 10. Okay. Now I've already got my list for 30, so I'm just going to rewrite those. That's going to be 1 and 30, 2 and 15, 3 and 10, 5 and 6. And now I'm going to do greatest common factor of 45. That's going to be 1 and 45. you can't do 2, but we could do 3 and 15. Can't do 4, but we could do 5 and 9. Excuse me. And that's going to be it. So now let's circle all the common ones. 10 doesn't work, but 15 works. Okay? So your common ones are 1, 3, 5, and 15. So the greatest common factor is going to equal 15. Now let's do 96 and 144. I did this one because it's really long. So if we do 96, and then we'll start 144 down here. All right, so we would have 1 and 96, 2 and 48, 3, don't put that comma there, 3 and 32, and 4 times 24, 6 times 16, and I think we can do 8 and 12. Is it divisible by 9? No. It's not divisible by 9. It's not divisible by 10. It's not divisible by 11. Okay? So now then, let's do 144. Well, we have 1 and 144. 2 and 72. 3 and 48. 4 and 36. 5 won't work. 6 will work. 6 times 24. 7 won't work. 8 will work. 8 times 18. 9 will work. So 9 times 16. And then we have, here's an odd one. Here we have 12 and 12. So we wouldn't list it twice, but 12 times 12 is 144. Okay, and now you know you're done, because now you're crossing over. You'll go to 16 and 9, 18 and 8. So we're definitely done there. So let's circle all the common ones. 1 and 1, 2 and 2, 3 and 3, 4 and 4, 6 and 6, 8 and 8, 12 and 12, 16 and 16, 24 and 24, 48 and 48, and that's it. So the greatest common factor, the GCF, is equal to 48. Remember, these are what we multiply together, factors, okay? All right, let's go to station 2, I believe. Oh no, it's just the same thing, but we're using word problems, okay? So now this is when you would actually do it. Now that you know how to do it, when would you actually use this? And this is kind of complicated to learn, okay? So let's do the first two together. It says, A says, there are 18 girls and 24 boys who want to participate in a trivia challenge. If each team must have the same ratio of boys and girls, what is the greatest number of teams that can enter? Find how many boys and girls each team would have. Okay, So we're going to have to list the factors of 18 and the factors of 24, and we're going to have to tell the ratio. If each team has to have the same ratio, what's the greatest number of teams that can enter? Okay, we're looking at how many teams they can enter. So if we do 1 and 18, 2 and 9, 3 and 6, 4 and 5 doesn't work. Okay, so we're done now. For 24, let me do this. 24, we're going to do 1, 24, 2 and 12, 3 and 8, 4 and 6. Okay, so let's look for common factors. And 6 is it. So the greatest common factor would be 6. They can have 6 teams that can enter. Now, what are going to be the ratios that they can have? Okay, well, we look at this, and that gives us our ratio. They would have 3 girls, because the 18 was girls and the 24 was boys. So we're going to have 3 girls to 4 boys. Okay? 6 teams with a ratio of 3 girls to 4 boys. Okay, let's do another one. B. Ski club members are preparing identical welcome kits for new skiers. The ski club has 60 hand warmer packets and 48 foot warmer packets. Find the greatest number of identical kits they can prepare using all the hand warmers and foot warmer packets. So since they've got a different number, they want to use as many as they can, but still be fair. Okay, give everybody the exact same. How many hand warmer packets and foot warmer packets would each welcome kit have? Okay, so we're going to do the same thing. Let's do 60, and these are the hand warmers. So the foot warmers is 48. Okay, and we're going to have 1 and 60, 2 and 30, 3 and 20, 4 and 4 and 15, 5 and 12, 6 and 10, 7 doesn't work, 8 doesn't work, 9 doesn't work. Okay, so we're done there. So let's do 48. We have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 doesn't work. Does 6 work? 6 and 6 and 8. Okay, and so now we're done. Because we're not going to, 7 doesn't work. 7 times 7 is 49. So then we're back to 8. So now let's circle them. Okay, that's it. So we're going to have 12 welcome kits. Okay. We want to know how many welcome kits. We're going to have 12. And what's going to be the ratio? The ratio will be 5 hand warmers to 4 foot warmers. Okay, now station 2, we have multiples and least common multiple. Okay, now let's look at choose one of these problems that you've not solved. Don't worry about that. You're going to do the ones that are highlighted still. I'm going to do the ones that are not highlighted. So now we're just listing multiples, okay? Which is just 9 times 1. Think of multiply when you think of multiples. So we're just going to multiply 9 times 1, 9 times 2. So we'd have for 9 and 12, we're going to have 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. Let's stop there. Now, the good thing about this is normally I only do maybe 3 to 5. I start out with maybe 3 to 5 and see if it works out. So normally I would have done maybe 5 of them. And then I would have come down here to 12 and I would have said, well, 12, 24, 36. Well, I've already got a least common multiple, so I'm going to stop and I'm going to say it's 36. I wouldn't normally do all of those, but I was just showing you if you don't run across one, keep going. But here, now that I know that I've already said 36, I know that my answer is going to be least common multiple of 36. Okay, now let's do 8 and 18. If I do 8, I got 8, 16, 24, 32, 40, 48, 56, 64. And I'm going to stop there and just try it. I have 18, 36, 44, not 44, 54, 54, 72, 90. Okay, so now I need to check and see, do I actually have one? I don't. So I probably need to jump up here to this one and see what goes on with 8 again. Well, if I jump up here, the very next one is going to be 72. And there are my least common multiple of 72. So that's the reason why I say sometimes you got to run it a long ways out there before you can find the common multiple. Okay, let's do 4 and 30. I'm just going to do 4 and 30 down here. I got 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And now, here's the problem. I know that's not going to work because 30 is going to be 30, 60, 90, 120. So let's just do 4 of those. Now, I got to keep going here. I got 44, 48, 52, 56, 60. Oh, good. There's my 60. 60 and 60. Okay. So maybe you want to start with the biggest number first and list a few of them, and then you can do your smaller one. Okay. Now, when are we going to use this? Well, it says the same thing. You're going to do C, and I think D and E on the next page. But A says hot dogs come packed 10 in a package. Hot dog buns come packed 8 in a package. Doesn't make any sense, does it? Why would you do that? If we want one hot dog for each bun for a picnic with none left over, what is the least amount of each we need to buy? How many packages of each item would we want to buy? So you don't want to waste any, but you also don't want to spend, or you don't want to buy 100 of each or whatever. So what's the least amount you can do? you always know what you could do is multiply the two together. You could do 8 and 10, and you could just buy that many. You could buy 10 hot dog buns, and you could buy 8 hot dog packs of hot dogs, and that would give you the right amount. Okay, it's going to give you 80 hot dogs and 80 hot dog buns. But we want to do the least common multiple. So let's do that. If we list let's do 10s and 8s, 10, 20, 30, 40. Hopefully you know that you're going to have 8, 16, 24, 32, and 40. There we go. So now you don't have to buy actual 10 hot dog buns and 8 packs of hot dogs. Now you're going to get 40 hot dogs with buns, and so you're going to have to buy 8. I'm sorry, you're not going to buy 8. You're going to buy, you actually write it like this. The least common multiple of 8 and 10 is 40. So you would have to buy 4 packs of hot dogs and 5 packs of hot dog buns. Because 5 times 8 is 40, 4 times 10 is 40, so that's your ratio that you would have to buy. Okay. B says, starting at 6 a.m., a bus stops at my street corner every 15 minutes. Also starting at 6 a.m., a taxi cab comes by every 12 minutes. When is the next time both a bus and a taxi are at the corner at the same time? Well, let's go with 15 and 20. And 12. We'd have 15, 30, 45, 60. Okay, and I know that 12, 24, 36, 48, and 60. So, now that's talking about minutes, right? It's talking about minutes. So, 60 minutes, let me write this as, let's see, 12 and 15 is equal to 60. 60 minutes would be 7 a.m. would be the next time that the bus and the taxi come to the street corner at the same time. Okay. Page 7. Let me make sure I had y'all do these. This has got you thinking about it a little bit. I want good examples, a lot of thinking here on those 2 answers. All right, I want to skip to page station 3. And it says, use prime factors to determine the GCF. Now, we're going to wait just a minute here. So here's another way of figuring out the greatest common factor of 2 numbers. It's called using prime factorization, and all that means is you're going to take the number like 30 and 50 and break it down into factors till there's nothing else. They're all prime. Okay, so a prime number, of course, is a number that you can only multiply by 1 in itself to get it. So like 11. 1 times 11, that's the only 2 factors that you can get to make 11. 17. 1 times 17 is 17. And of course, like 2, 3, 5, those numbers. Okay, so if you see here, they broke 30 down to 2 and 15. Well, 15 can break down to 3 and 5. So what they said was that the prime factorization is 2, 3, and 5. So they graphed that in this yellow circle here, 3, 2, and 5. And since we have 50 can break down to 2 and 25, 25 can break down into 5 and 5, well, this has common factors of 2 and 5. And then it only left this 1 5 out here because this only had, the 30 only had 1 5. Okay. Same thing for this one. 30, well, that's all the same stuff. 2 and 15, well, 15 breaks down to 3 and 5. Now 45 can break down to 3 times 15, and then it can do 3 and 5. Okay, so just for example, if we did 45 and we broke that down, what if we broke that down to 9 and 5 instead of 3 and 15? Well, this breaks down to 3 and 3, and we still have the same numbers. Okay, see that? So it doesn't matter how you break them down. Whenever you're breaking it down into prime factorizations, you'll always break them down into the prime numbers. Okay, so that's the same thing for the rest of these. I just want you to take a look at those and make sure you can do those. Okay, so maybe just come down here and maybe see if you can do 60 and 15 a different way. Well, I just done 9 and 5. 60 you could do 4 and 15 maybe. So just see if you can break those down differently. Okay. And you're going to answer all of those questions whenever you're doing that. Okay. So apply factors to distributive property. Okay, distributive property is a property when we're doing multiplication that we can multiply by the same numbers. Okay, so choose one. Well, we're going to do 1, 2, and 3 together, and then you're going to do 4, 5, and then these over here I want you to do as well. Okay, so let's do 1, 2, 3. It says find the GCF of the two numbers and rewrite the sum using distributive property. Okay, so let's do 12 and 18. Let's do prime factorization since we haven't done a lot of those. We can say 3 and 4. This would be 2 and 2. If we do this, we have 6 and 3. Okay. This would be 3 and 2. Okay. So if we go back and look at these, what is in the middle? I don't think I mentioned this. I didn't. That was bad. We would look at this and say, what's in the common factors? We can multiply those together. So 2 times 5, and that gives you the 10. Here, 3 times 5, that gives you 15, and those are your common factors. Your greatest common factor is 3 times 5. Okay, you break it down into the common factors, and then you can multiply them together. Okay, forgot to mention that. Now, we keep coming here. Now we could do the 2 circles. Common ones are 3 and 2 and 3. Hold up, let me see here. So we're going to have 3, another 3, no, not another 3. We're just going to have that 3, this 2, another 2, and then another 3 here. So we would have 6 as the greatest common factor. Okay. So since 6 is the greatest common factor, we could break that down into, since 6 is going to be our number out front, we're going to have 6. Well, how do we get 6 to be 12? Multiply by 2. 6, how do we get 6 to be 18? We multiply by 3. And that's going to give you 6 times 5, which is equal to 30. Okay, so 6 times 5 equals 30, and we also know that 12 plus 18 equals 30. So it works out like that. All right, I'm going to erase this all, and we'll do number 2. Number 2 is 42 plus 14, so we're going to do, I'll do one more prime factorization of this. We have 7 and 6. We have 3 and 2 because 6 will, now 7 is prime, so we don't have to worry about that one. But we have 6 where it's 3 and 2, so let's do 14. We have another 7 and 2, so if we were to put those together, we would have 7, 3, 2, oh, we have 7 on both of them actually. So we can put both of those in the graph there, or in the Venn diagram, which means we would do 7 times 4, which is, 7 times 2, which is 14. So 14 is the greatest common factor. And so if we do that, then we're going to come up here and we're going to say 7 times 6 and plus 7 times 2. And then 7 times 6 is 42 plus 14, which is exactly what we got right here. So we know that that's going to equal 56. So that all works out. Now, let's do one more, and instead of doing prime factorization, let's do just listing it. So if we do 36 and 27, that's 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 times 6. That's over 27. We would say 1 and 27. 2 won't work. 3 will. 3 and 9. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't, and 8 does not. So, what's our greatest? Let's circle our common factors. 3, 9, 27's not, so 9 is the GCF. Alright, so let's break this down. This would be 9 times, so 36 divided by 9 is 4, plus 27 divided by 9 is 3. Okay, so we can say 9, times 7 is 63. We'll just add these two together and we get 7. So that's 63. So let's check and see. 36 plus 27. Carry my 1. That is 63. So, yep. That equals those. Alright, so now you're going to go and do 4 and 5 and the rest of this, which looks like I've already unhighlighted this a while ago. So let me go back and highlight that. so that you know to do it as well. Oh, that's a little bitty highlight. Okay. Do that one as well. And let's see, what else do we have here? Okay, that's it.